Good morning. So today we are in the session that is module 5. Okay, I hope you can see. That is today it is students T test for a sample mean. I am discussing about that. Students T, the different types of test. The question will not come theoretical, but only the you have to know how to solve the problems in each type of test, especially the hypothesis, null hypothesis, H1, opposite of null hypothesis, then other concepts like significance tests, then students T distribution tests, and coming you'll get today we'll finish all the theory and we'll start one problem. Okay, so students T test for a sample mean question. So we need to test the hypothesis. So what is the hypothesis? Hypothesis means one assumption. So here we have to test the hypothesis whether the sample mean x bar differs, whether the sample mean x bar differs significantly from the population, whether the sample mean x bar differs significantly from the population mean. So sample means, for example, you have to test the number of the condition of the switches. There are 1,000 switches, one load of switches. So what you do, you take arbitrarily about one switch from each box. That is called sample mean. And we find out the condition of that. And also there will be the total population 1,000. You're not checking everything. And the condition of that arbitrarily taken. So is there any difference? I hope you followed. I explained in a general way. Whether the sample mean x bar differs significantly from the population mean mu, or the hypothetical value mu. That is the mean of the population. Population means the full group that is under study. Okay. Now here what we do, we compute t equals x bar minus mu by s into root n. So we calculate or we compute t equals x bar minus mu by s into root n. Okay. We compute t equals x bar minus mu by s into root n first. X bar is the sample mean, mu is the total mean of the population, s is the variance that we'll see later what it is, and root n, number of members or elements. And consider mod t. The mod t value will be given, that is from the students T distribution. The value will be given, or if the value is not given, the table will be given. Now, if mod t is greater than t.05, if mod t is greater than t.05, see t.5%, 5% value, the difference between x bar and mu is said to be significant. See, the hypothesis what you have taken. If the mod, when you find this t, then we take mod t. Mod t means absolute value. If mod t is greater than t.05, 5% value, that is, it is given in the table or the value will be given in the problem. The difference between x bar and mu is said to be significant. Then the difference between x bar and mu is said to be significant at 5% level of significance. And the difference between x bar and mu is said to be significant at 5% level of significance. If it is greater than t.01, okay, another value will be given, that is 1%. T distribution 1%. If mod t is greater than t.01, the difference is said to be significant at 1% level of significance. Then the difference is said to be significant at 1% level of significance. Then the difference is said to be significant at 1% level of significance. Here is greater, here means it is significant at 5% level of significance. If it is greater than t.01 means it is significant at 1% level of significance. If mod t is less than the table value at a certain value of significance, the data is said to be conformal or consistent with the hypothesis. That is, mu is the mean of the population. That is, mu is the mean of the population. Okay. What it says, if mod t is less than the table value, that's here all greater means the difference is said to be significant. But suppose it is less. If mod t value is less than the table value at a certain level of significance, it is less than the table value at a certain level of significance, then the data is said to be consistent. Data is said to be same. Data is said to be conformal, or the data is said to be consistent with the hypothesis. Data is said to be consistent with the hypothesis that mu is the mean of the population. So data is correct. What you have assumed is correct, that Mu is the mean of the population. Okay. So greater than means significant value we have to take. Less than means it is said to be consistent or conformal with what you have assumed. It is said to be consistent or conformal with what you have assumed. Okay. Now, note, if you take the note, we have 95% confidence limits for mu. See, we have 95% confidence limits for mu given by the formula is x bar plus or minus s by root n into t of 0.05. So later on you will see how to use this in problems. Now you might get confused or read it, understand it. Then later on you will see how we will use it in problems when I solve the problems. We have 95% confidence limits for mu given by x bar is equal to plus or minus s by root n t of 0.05. Similarly, this is for 95% confidence. Similarly, 99% confidence limits for mu is given by x bar plus or minus s by root n t of 0.01. Same, only difference is here you have to write 0.05, here you have to write 0.01. That's all. Now, test of significance of difference between sample means another. This was what we studied first was the test of significance of, what is that? Student t-test for a sample mean. It was student t-test for a sample mean. Now we are studying test of significance of difference between sample means. Last session we have studied what is a student t-test and all that. That was a continuation. Now another type of test of significance. So test of significance. So it is test of significance, the test of significance of difference between sample mean. Test of significance of difference between sample means. So consider two independent samples. Difference sample means. Consider two independent sample, that is xi, I1 to 3 till n terms, that is x1, x2, x3, x till x4 till xn terms, and yj. J is equal, okay, I1 to 3 till n1 terms, and yj. J is 1 to 3 till n2 terms. So consider two independent samples, xi and yj. Consider two independent samples, xi and yj, drawn from a normal population. Normal population. Let x bar and sigma x, y bar and sigma y respectively be the mean and variance of the two samples. Variance and standard deviation are very closely connected. They are square and square root. That's all. So x bar comma sigma x and y bar comma sigma y respectively be the mean and variance of the two samples. Be the mean and variance of the two samples. Be the mean and variance of the two samples. Let mu be the population mean and sigma be the population variance. Let mu be the population mean and sigma be the population variance. Let mu be the population mean and sigma be the population variance. Mu is what? Mu is the population mean and sigma is the population variance. We need to test the hypothesis whether the difference between the sample mean is significant. So what is hypothesis? Difference between the sample means is significant. Hypothesis means we assume. In the problems, we'll assume some other thing. So testing that, you're testing your assumption, testing your hypothesis by using the difference between the sample means comes in this concept. I hope you understand what we are doing. So we need to test the hypothesis. We need to test the assumption between the difference between the sample means is significant. We need to test the hypothesis whether the hypothesis means assumption, whether the difference between the sample means is significant. So totally this chapter is like that. First we assume something, that is called hypothesis, and then we test for that hypothesis. And then according to the different type of test, the rules, if they are correct, our assumption is correct. If it is wrong, our assumption is wrong. Like that. This is the procedure used in this module, in this part, in this module, in this sampling theory, hypothesis testing, etc. Okay. Now, what we do? So, what we have to do? We need to test the hypothesis whether the difference between the sample means is significant. We need to test the hypothesis whether the difference between the sample means is significant. So, what we do first? We compute t is equal to x bar minus y bar. We compute t is equal to x bar minus y bar divided by s into square root of 1 by n1 plus 1 by n2. We compute t equals x bar minus y bar divided by s into square root of 1 by n1 plus 1 by n2. This is the formula. See here the formula is, so it's called difference. The name itself says difference between the sample means. So t equals, we compute t using the formula x bar, that is the mean of the x values, y bar, the mean of the y values divided by s into square root of 1 by n1 plus 1 by n2. Okay. What is this s? See, s is calculated in this method. See, where s squared equals, it looks complicated, it's very simple. 1 by n1 plus n2 minus 2, where s squared equals 1 by n1 plus n2 minus 2 into sigma I is equal to 1 till n1 xi minus x bar. Sigma I is equal to 1 till n1 xi minus x bar squared plus sigma j is equal to 1 till n2 yi minus y bar squared. So this is the method to find s squared. You will see later when solving problems how we do it. Okay. Now here, degrees of freedom. Degrees of freedom also in the last session we said if there are n variables, there are n minus 1 degrees of freedom, something like that we have discussed. So degrees of freedom here v equals, the notation for degree of freedom is v. Degree of freedom v equals n1 plus n2 minus 2. Degree of freedom v equals n1 plus n2 minus 2. Now, if after calculating this t, we take the absolute value of this. If mod t is greater than t of 0.05, that is 5%. Mod t is greater than t of 0.05. If mod t is greater than t of 0.05, that means 5%. Okay, what is this t of? That will be given in the question. T of 0.05 will be given in the question or the table will be given. Okay, after you get t, you take the absolute value of t. If that absolute value of t is greater than t of 0.05, the difference between the sample means is said to be significant. See, the difference between the sample means is said to be significant. Okay. The difference between the sample means is said to be significant at 5% level of significance. Similarly, if it is greater than, mod t is greater than t of 0.01, then we can say the same thing. The difference between sample means is said to be significant at 1% level of significance. Similarly, for 1% level of significance also. So after finding t from here, mod t, that is compared with the t of 0.05. That value will be given in the question. That value will be given in the question. The difference between the sample means is said to be, so that is a hypothesis. See? The difference between the sample means is significant or not. That was the hypothesis. So if it is greater, we say that it is correct. Whatever assumption is correct. The difference between the sample means is said to be significant at 5% level of significance. Similarly, if it is given 1%, then mod t greater than t of 0.05. Now, the very important part, surely one question will be there in this also, students t distribution. Then the important is this also, chi-square distribution. The last concept in this, chi-square distribution. So, chi-square distribution means CHI. So, chi-square distribution means it is given as CHI, the pronunciation, chi-square. Okay, chi-square distribution. So, chi-square distribution provides a measure of correspondence between the theoretical frequencies and observed frequencies. So first of all, you should know what is the use of this chi-square distribution. Chi, CHI, that is a Chinese, very famous distribution. So what is its work, or what we get from this chi-square distribution? It provides a measure of correspondence. It provides a measure of correspondence between the theoretical frequencies and observed frequencies. Okay, what is this theoretical frequencies and what is this observed frequency? We'll see when we solve the problem. So again I repeat, the chi-square distribution provides a measure of correspondence between the theoretical frequencies and observed frequencies. So if OI, if we take OI, I is 1 to 3 till n terms. In the question it might be 1 till 7 or anything. And I is equal to 1 to 3 till n terms, respectively denotes the, these two respectively means in order, denotes the set of observed and estimated. O means observed, it denotes the set of observed. E means estimated, denotes a set of observed and estimated frequencies. Respectively denotes a set of observed and estimated frequencies. The quantity chi-square is denoted by quantity chi-square. See, chi-square symbol is like this. All of you note down the symbol here, just like this and on bar. Like this you are writing and on bar. Square, chi-square. The quantity chi-square denoted by this symbol, again if it comes in the exam or anywhere, it means chi-square, is defined as follows. So the formula, very important formula, chi-square equals sigma I is equal to 1 till n terms OI minus EI squared divided by EI. Degrees of freedom, because the n, it is 1 less n minus 1. Again I repeat, chi-square formula. This is the symbol for chi-square. This is the word chi. Okay, chi-square is equal to sigma I is equal to 1 till n terms. OI minus EI squared. OI minus EI squared divided by EI. And here the degrees of freedom is n minus 1. Now we'll see this chi-square, observed frequencies minus expected frequency square divided by EI. And degrees of freedom is, if there are n variables, n minus 1. Phi is equal to 1 till n terms, degrees of freedom is n minus. Okay, chi-square test as a test of goodness of fit means when you draw the graph, how far we can assume that the graph is correct, totally correct. Goodness of fit means the actual plot of the graph and what you got from calculation, both are correct. How we know? So chi-square test helps us to test what is the use, what is the application of chi-square test. It helps us to test the goodness of fit of these distribution. Chi-square test helps us to test the goodness of fit of the distributions like binomial, normal, Poisson. All this you studied in module 4. Binomial means Bernoulli, another name. Binomial distribution or Bernoulli distribution, normal distribution and Poisson distribution. So chi-square test helps us to test the goodness of fit, helps us to test the goodness of fit of the distributions like binomial or Bernoulli, normal distribution and Poisson distribution to a given data. If the calculated value of chi-square is less than the table value is also there. So if the calculated value of chi-square is less than the table value of chi-squared at a specified level of significance, the hypothesis is accepted. Accepted means correct, taken. Otherwise, the hypothesis is rejected. So very important point here come across. If the calculated value of chi-square, if the calculated value of chi-squared is less than the table value of chi-squared, see, chi-square value what you get from calculation is less than the table value. Table value either they give in the problem or they will give you the table. So if the calculated value of chi-square is less than the table value of chi-squared at a specified level of significance, the hypothesis accepted. So if the calculated value of chi-square is less than the table value of chi-squared or given value of chi-squared, then the hypothesis is, your assumption is accepted. Otherwise, your assumption is rejected. Now we will see a problem here, one problem. Okay, that ends your theory part. That ends your theory part here. Now one problem. So problem also I have divided according to the theory of the sampling. For example, now first problem I'm solving in 2 or 3 problems I'm solving in this, that is sampling distribution of the means. You can see the notes before and see the theory of that. So now the problem what I'm solving here is in the concept sampling distribution of the means. Is in the concept sampling distribution of the means. I have already discussed that in the first session of or the second session of sampling theory. Okay. So see the problem. Exam they will not give which theory and all that, you should judge. A population consists of 4 numbers 3, 7, 11, 15. A population consists of 4 numbers 3, 7, 11, 15. A. Find the mean and the standard deviation of the sampling distribution of means. Find the mean and standard deviation of the sampling distribution of means by considering samplings of size 2. By considering samplings of size 2 with replacement. So find the mean and standard deviation of the sampling distribution of means. See, here the word itself comes. Find the mean and standard deviation of the sampling distribution of means by considering sampling of size 2. By considering sampling of size 2 with replacement. Okay, with replacement it is given. Okay. Second part of the question, that is 1b. If n comma n, capital N comma small letter n, denotes respectively the population size and sample size. So capital N is population size, small letter n is sample size. Sigma and sigma x bar respectively denotes the population standard deviation and standard deviation of the sampling distribution. So sigma and sigma x bar respectively denotes the population standard deviation and sigma x bar standard deviation of the sampling distribution of means without replacement. See here with replacement, this is without replacement. You know what is replacement, what is without replacement. Replacement means the variables are added again and again. Without replacement, once they are removed, they are not considered for calculation. So of means without replacement, verify that one. So you have to verify it. Sigma x bar squared is equal to sigma squared by n into capital N minus small letter n divided by n minus 1. And second sub question is, this all comes under first. Second sub question is mu x bar is equal to mu, where, so mu, we have to show that, actually we have to check whether mu x bar is equal to mu, where mu x bar is the mean of the distribution, where mu x bar is the mean of the distribution, mu x bar is the mean of the distribution, and mu is the mean of the population. Okay, now first we start, see, population mean. Population consists of 4 numbers, 3, 7, 11, follow attentive, be attentive, it's very easy, you can use your calculators. So mean, population mean mu equals 3 plus 7 plus 11 plus 15, because there are 4 numbers, divided by 4, just correct whether I am right or wrong, it is 9. Okay, you get the answer as 9. Okay. Now, population variance, so sigma squared, the formula is there, 1 by 4 x minus x bar. So 3 minus 9, x bar mean, xi minus mu. So 3 minus 9 whole squared, x variance, xi minus x bar, you know that formula. So plus 7 minus 9 whole squared, plus 11 minus 9 whole squared, plus 15 minus 9 whole squared. Calculate this, you will get 20. So mu equals 9 and sigma equals root 20. This is clear. Mu equals 9, sigma equals root. We calculated for the population, mean and standard deviation. Okay. Now A, what is that? Find the mean and standard deviation of the sampling distribution of means by considering samplings of size 2, by taking 2, size 2 with replacement. Okay, what is this size 2? For that, let us consider the samples of size 2 with the replacement. So let us consider the samples of size 2 with replacement. See how to write. With replacement is just like repeated. Let us consider the samples of size 2 with replacement. See, they are written as follows: 3, 3, 3, 7, 3 comes again, replacement. 3, 11, 3, 15. I hope you got 3, 3. Size 2 means 2 numbers, 3 and 3, 3 and 7, 3 and 11, 3 and 15. Size 3 means 3, 3, 7, like that. So 3, 3, 3, 7, 3, 11, 3, 15. Then 7, 3, 7, 7, 7, 11, 7, 15. So 3, 7, 11, 15 can be written in so many possible ways with replacement. 11, 3, 11, 7, 11, 11, 11, 15. Okay. 15, 3, 15, 7, 15, 11, 15, 15. So 11, 15, 15, 11, like that, the replacement. Now, sampling means are as follows. So how we find the sampling means? Sampling means, see, 3 plus 3, 6 by 2, that is 3. 3 plus 7, 10. 3 plus 7, 10. The mean of this is 5. 11 plus 3, 14 by 2, 7. 15 plus 3, 18. 15 plus 3, 18. 15 plus 3, 18 divided by 2, 9, like that. I found the the mean of this sampling means. 7 plus 3, 10, that is 5. 7 plus 7, 14, 7. 7 plus 11, 18, that is 9. 15 plus 7, 22, so 11, divided by 2. 2 items means 2, 3 items means 3. So like that, for this 7, for this 9, add and divide by 2, the mean, average. 11 plus 11 by 2, that is 22 by 11. So 11 plus 11, here you get 11 plus 11, what you get? 22, that is 11. 11 plus 15, 26 by 2, 13. 15 plus 3, that is 18 divided by 2, 9. 15 plus 7, 22 by 2, 11. 15 plus 11, 26 by 2, 13. Hope it is clear. 15 plus 15, 30 by 2, 15. So these are the sampling means. The frequency distribution of the sampling means. So we want now the frequency distribution of the sampling means. Okay. X, we write all the values. What are the values? 3, 5, 7, 9, 11, 13. So all the values here we are writing, not the given here. Here, 3, 5, 7, 9, then 11, then 13, then 15. Okay. 3, 5, the frequency distribution of the sampling means. That is 3, 5, 7, 9, 11, 13, 15. So 3, it occurs 1 time. 5, it occurs 2 times. Okay. 7, it occurs 3 times. Very easy. 9, it occurs 4 times. 11, it occurs 1, 2, 3 times. 13, it occurs 1 times, 2 times. 15, it occurs 1 time, like this. Then we find mu x bar. Mu x bar is, you know already to find mean. Sigma fx by sigma f. What we do? Sigma fx, 3 into 1, 3, plus 5 into 2, plus 7 into 3, plus 9 into 4, plus 11 into 3, plus 13 into 2, plus 15 into 1. You will get 144. Just do it in the calculator. Sigma f means add all of this. You will get 16. So 145 by 16 is 9. And the standard deviation formula sigma x bar squared is equal to sigma f into x squared. So frequency into x squared divided by sigma f. So here 1 into 9 plus 2 into 25 plus 3 into 49 plus 4 into 81 plus 3 into 121 plus 2 into 169 plus 1 into 225. So you'll get 1456. Add it. Divided by sigma f. Add all this, you'll get 16 minus mu of x bar, this 9 squared, you'll get as 10. So mu of x bar is 9 and sigma x bar is equal to 10. So remark, what is your what we get from this? So mu of x bar is equal to mu. See here, mu of x bar is equal to mu. You can see here mu of x bar is equal to mu and sigma x bar is equal to 10. You got mu of x bar is equal to mu and sigma x bar squared is equal to sigma squared by n. If you calculate, see, because sigma squared is here, sigma squared is 20, sigma squared is 20, sigma squared is 20 and n is 2. So 20 by 2 is 10. So sigma x bar squared, so sigma squared is 20, 20 by 2, 20 by 2 is what? 10. So sigma x bar squared, is equal to 100. That is 20 by 2. Is it clear? Are we getting this? Or is it proper? Sigma squared is 20 by 2. So sigma x bar will be square root of, that is sigma x bar will be equal to the value. Both the values are correct. I hope it is clear. Just check it. Sigma x bar squared will be 100 here. So sigma x bar will be equal to sigma squared by n actually. Sigma x bar will be equal to sigma squared by n. Anyway, this is the remark I have given, just not important. Now B, second part of the question is, if n comma n denotes respectively the population size and sample size, sigma and sigma x bar respectively denotes population of standard deviation and standard deviation of the sampling distribution of means. Without replacement, verify these two. Sigma x bar squared is sigma squared by n, n minus n divided by n minus 1. Mu x bar is equal to mu, where mu x bar is the mean of this distribution and mu is the population mean. Okay. So for B, let us consider the samples without replacement. So without replacement, with replacement means what I have written above. This is with the replacement. Now without replacement, okay, 3, 7, 3, 11. See, not replaced. 315, size 2, without 315, 3, 7, 3, 11, 315. That's all. 3, 3. Replacement is not there. 3, 3. No. Okay. Then 7, 11. 11th, 7, 11. Then 7, 3 not there because no 7, 3, 7 is there here. We cannot write. 7, 15. We cannot write 7, 15. Okay. 15, 7. Then we get here 11, 15. 11, 15. Okay. 11, 15 is there. So 15, 11 we can't write. 7, 15 is there. So we can't write 15, 7 like that. So 7, 11 is there. We can't write 11, 7. So I hope you follow. This is without replacement. The sampling means are the 3 plus 7 by 2. That is 5. 11 plus 3, 14 by 2, 7. 15 plus 3, 20. 18 by 2, 9. Here 18 by 2, 9. 15 plus 7, 22 by 2, 11. 15 plus 11, 26 by 2, 13. Mean. Just add and divide by 2. Size 2 means 2 elements. Now mu of x bar. Add everything, divide by the 6 elements. So 9. So mu of x bar is equal to mu. Here mu is there. See. Mu value 9. So mu of x bar is equal to mu. So first part we have proved. See, mu of x bar is equal to mu. Now this one, second one, that you have to prove. Okay? Mu of x bar is equal to mu. Then sigma x bar squared we calculate how? 1 by 6. 5 minus xi minus x bar whole squared. So 5 minus 9, mu x bar is the mean. Xi minus x bar is the mean. So 5 minus 9 whole squared plus 5, 7, 9, 11, 13. The elements are 5, 7, 9, 11, 13. So 5 minus 9 whole squared plus 7 minus 9 whole squared plus 9 minus 9 whole squared plus again 9 minus 9. This we are taking. See here. 5 minus 9 whole squared plus 7 minus 9 whole squared plus 9 minus 9 whole squared plus 9 minus 9 whole squared plus 11 minus 9 whole squared plus 13 minus 9 whole squared will be 40 by 6, 20 by 3. Now we have to show this. This is there in the question here. See. So I wrote it. I have to show left hand side is equal. This already I showed, second part. The left hand side is equal to right hand side I have to show. I have to show left hand side is equal to right hand side. So I wrote it here. Okay. Now we take the right hand side. Sigma squared. Sigma squared is here 20. From here you got it. See. Sigma is root 20. Sigma squared is 20. Okay. Sigma squared 20. I took the right hand side. By n is 2. Size 2. Capital N is 4. 4. Why 4? Because given in the questions here. Sample. How much is? See. 3, 7, 11, 15. So capital N is 4. 4 minus small n, the size you have to form without replacement, that is 2 divided by capital N 4 minus 1. That will be, we calculate, you will get 10 into 2 by 3, 20 by 3, and 20 by 3 is nothing but here sigma x bar squared, so LHS. So I proved the given result. So we have proved the given result, that is left hand side is equal to right hand side. So next class onwards, we are continuing the problems. Please see this problem even if the voice is not audible. Please adjust because it's online class. We have to complete the syllabus, see the PDF notes, complete the notes, write and study. Okay, and see the group. Always see the maths group. I'll put some anything new assignment is there. I'll put it. Okay. Any doubt you can contact me. So I wind up the session here. Thank you. All the best.